Hey guys, welcome to Infinite Insight Geometry, Lesson 1.2, How Mathematicians Prove Things. Alright, let's get started. So, here we can see two even numbers adding up to another number, which also seems to be even. 2 plus 2 is 4, 4 plus 4 is 8, 6 plus 8 equals 14. Adding two even numbers makes an even number. I would think this is pretty standard knowledge at this point. But did we prove it? Well, not really. We just gave a couple of examples. If we want to prove that adding two even numbers makes an even number, we had to prove that for every single scenario, every single even number. And since there's a lot of even numbers, an infinite amount of even numbers, this would be almost impossible to do by hand. So, how do we really prove this statement? Adding two even numbers makes an even number. Well, we used inductive reasoning at first to predict a pattern. We saw that usually two even numbers creates an even number by adding them. But we only gave it for a couple of examples. That's inductive reasoning. That's prediction. How do we prove it? By using deductive reasoning. Well, here's the entire proof. As you can see, it's pretty long, but if you can see the logic behind how it works, it's really not that bad. If you have two even numbers, then they're both divisible by 2, so when you add them, they will also be divisible by 2. Therefore, two even numbers, a and b, will always equal another even number. The key to deductive reasoning is using logic that works in every scenario that you can think of. By using definitions, postulates, and theorems, we can analyze what we can do. So, here are the general steps to proving statements. You gotta understand the problem. You gotta get the definitions, postulates, and theorems that you need, and then you gotta put it all together. Alright, step 1. Understanding the problem. You can't solve a problem about angles by using a theorem about size. You gotta use the correct tools. You gotta use the correct statements. You gotta use the correct definitions. You gotta understand what you're doing and how to do it. The second step is definitions, postulates, and theorems. Definitions are statements that explain the exact meaning of the word. For example, if you get a dictionary, you would get a lot of definitions, and those are the exact meanings of that word. Geometry definitions aren't different. They are the exact meaning of a word. And if something means something, then that's the definition. Postulates, or if your teacher or anyone else you want call them axioms, postulates and axioms are the same. They are statements that are assumed to be true without proof. Now, postulates are really, really important because without them, we can't have a foundation in which we build ourselves on. Geometry is built upon the postulates that we give. So we don't really need to prove them because they are assumed to be true. Now, theorems are a little bit different. Theorems, we can prove theorems using the postulates. We just use them as a shortcut because using all of the postulates in a row is really, really tiring and consists of a lot of hard work. We use theorems as a shortcut because we've already proven them to be true. We build upon the foundation. Think of it as the postulates are the foundation, and then theorems are all the layers above it. You build a skyscraper of proofs upon the foundation of postulates, and theorems are the floors. And then you gotta put it all together. You gotta use the definitions, the postulates, the theorem. You gotta use them in the correct order though. We're gonna see what that looks like later on in the course, but knowing how to put it all together is the heart of proving statements. And that'll be all for today's lesson. thank you guys. Thank you for watching. This is lesson 1.2. Be sure to like and subscribe. Comment down below if you have any questions. I have my Gmail down in the description below. So if you have any questions, feel free to email me. I'll try my best to explain anything that I can. And I will see you next time. Thank you. See you.